Feel it coming in the air. Hear the screams from everywhere. I'm addicted to the thrill. I'm ready.
Welcome to 8.5 Part 2B, Complex Fractions. We need to look at simplifying complex fractions. So if we start with the first example on review, we have fractions within fractions. We need to look at this line being our division symbol. And remember, if we're dividing, it's really the same as multiplying by reciprocals. If we rewrite this equation, we're going to take 3/5 times, if we flip the 12 35ths, we're going to have 35 over 12. Now we have 3 times 35 and 5 times 12. If we can reduce, we try to, so make that a 7. 3 goes into 12, 4. So our answer is 7 on top and 4 on bottom, so 7/4. Okay. With rational expressions, it's kind of the same thing. We need to get to that first step like 8/4 and 8/5a, where we need to just rewrite it so it looks like a multiplication problem, hopefully then factor, and then cancel and write restrictions. So on the first one, if we take the first fraction and we have 8, or x to the 4th minus 81, divided by 3x squared plus 27, okay, times, and then we're going to take the x squared minus x minus 12 and flip it. So we have x over that x squared minus x minus 12. Now if we can, we try and factor. So this top actually factors 2x squared plus 9, x squared minus 9. Okay, we still have the x over here. If we take out the 3, we're going to get x squared plus 9. And if we factor the polynomial underneath the x, we're going to get x minus 4 times x plus 3. Now we look, is there anything that we can cancel? Well, we know x squared goes into x squared. There really isn't anything left there. But if you notice, we still have this x squared. So we can actually take it a step further. And if we come directly over here, we know that x squared minus 9 becomes x minus 3, x plus 3 over 3, times x over x minus 4, x plus 3. Now we can cancel out the x plus 3, the x plus 3, so we're left with x times x minus 3 all over 3 times x minus 4. Okay. Restrictions, if we kind of go back to the very beginning, remember the division. So if we look at this in green, nothing is going to make the x squared plus 9 become 0. But on the right other side, we know that if when we invert it and start it off with many, x cannot equal 0, and x cannot equal 4 and negative 3. Number 2. Again, complex. So we're looking at a bunch of things. So let's start at the left and then work over. We're going to have, if I try and rewrite, we're going to have x minus 4 over x minus 7 times, we'll take the top 2, we have x squared minus 49 over 3x minus 12, divided by x squared plus 14x plus 49 over x plus 5. Okay. Now if we factor, and then we're going to flip the division side and make it multiplication, we would get x minus 4, x minus 7, times x minus 7, x plus 7. Take out a 3, and that gives us times x minus 4. And then when we times, we'll have an x plus 5 on top, and an x plus 7, x plus 7. Domain restrictions, if we look at this, let's take, we know it cannot be, so our di, we know x cannot be 7. We know it cannot be 4, and then both on the far right, so negative 5 and plus or minus 7. So we already, or sorry, negative 7. Okay, so we end up having 4 restrictions. If I go through and cancel, there's a minus 4 cancels with a minus 4, a minus 7 cancels with a minus 7, a plus 7 cancels with the plus 7, and I think that's it. So on top, we're left with x plus 5 over 3 times x plus 7. X cannot equal plus or minus 7, 4 4, and negative 5. Any questions? Just kidding. All right, now, if we look at this where we have multiple fractions added and we need common denominators, what we can do is we can multiply numerator and denominator by the LCD of all denominators and then simplify. For instance, if you look at the top, okay, up here, we have an x in the bottom and a y in the bottom. Okay, and remember, this is our division sign. Okay, and then on the bottom we just have a y. So the common LCD, if we look at this, is we're going to need an x, we're going to need a y, and then on the bottom we need a y. So we're going to multiply this whole thing by x times y. So if we take this x times y and we multiply it by 1, we're going to get x times y over x plus, this becomes x squared y over y, okay? Or you can look at it as x times x, okay? Divided by, if we do the same thing on the bottom, xy over y plus xy, and if you want, you can put it over 1. If we simplify, just within the terms, this x cancels with this x, this y cancels with this y. By canceling the y's, we're going to get, and the x's, we're going to get y plus x squared over this y cancels with this y, and we're going to get x plus xy. From here, is there anything we can take out or simplify? Nothing we can simplify on top, so it can't do anything there. So there's our answer. Number 4. Okay, if we do the same thing, remember this is our division sign. Okay, in the fraction we have just a y. So for our LCD, we need a y, and on the bottom we need an x. So again, we're back to x times y. So we're going to multiply xy to both top and bottom everything if we have this complex rational expression. So xy times 3x, so we can go 3x times xy minus xy over y all over. This becomes xy times y squared over x plus xy times x. Okay, if we can cancel out anything, then let's do so. So on top, we know the y's cancel. Over here we're left with what? 3x squared y minus x all over x cancels with x. We end up having y cubed and then plus x squared y. Notice we have 2 terms on top, 2 terms on bottom. If we can factor, let's factor just to see. So we can take out an x, and we're left with 3xy minus 1. And I can take out a y, and we get y squared plus x squared. Okay, nothing cancels, so really this answer would be okay. This answer would be okay. We are through with complex fractions. Congratulations. Remember, do your best, forget the rest. Bye for now.